Hello everyone. Today we will learn about high voltage switchgear. Today's learning content mainly covers three aspects. They are the types and characteristics of high voltage switchgear, structural components, and understanding the precautions when operating high voltage switchgear. High voltage switchgear is a general term for metal enclosed switchgear. It is actually according to certain circuit schemes. It assembles related electrical equipment into a closed metal housing, forming a complete distribution unit. With the continuous change in demand and the continuous development and improvement of technology, high voltage switchgear has become more diverse in its forms and types. Now, let's look at the common types of high voltage switchgear and their respective characteristics. Common types of high voltage switchgear and their respective characteristics. Common classifications of high voltage switchgear and their structural characteristics are shown in the table. It can be classified according to the installation form of the circuit breaker, the composition of compartments, and the insulation medium for classification. According to the installation method of the circuit breaker, they can be divided into fixed type and withdrawable type. In fixed type high voltage switchgear, the circuit breaker is fixedly installed, and in this type of high voltage cabinet, there's an isolating switch installed. In the withdrawable type, the circuit breaker or the main components inside the switchgear are made as a movable card, which can be easily removed from the cabinet. For fixed-type switchgear, its cabinet space is relatively spacious, making maintenance easier and easier to manufacture. However, its safety is relatively lower. For withdrawable switchgear, the circuit breaker can be removed from the cabinet, so maintenance is convenient. Additionally, it does not require an isolating switch, so the overall structure of the switchgear is relatively compact. According to the different compartment structures, they can be divided into semi-enclosed type, box type, partitioned type, and armored type. According to the insulation medium, it can be divided into air-insulated, composite insulated, and SF6 insulated, three types. Next, let's get to know the structure of switchgear. Previously, we learned that there are many types of switchgear. The structural characteristics of different switchgear are also different. The leftmost picture is a fixed-type switchgear. The middle one is an armored switchgear. The rightmost one is a box-type switchgear. Take armored switchgear as an example. Armored switchgear, it mainly consists of four parts. Busbar compartment. It is located at the upper rear part of the switchgear, mainly used for installing busbars, a compartment space. Instrument compartment. It is located at the upper front part of the switchgear, mainly used for installing some monitoring instruments, protective relays, switchgear control power switches, etc. Cable compartment. It is located at the lower rear part of the switchgear. It is mainly used for installing outgoing cables and grounding switches, transformers, etc., and other auxiliary equipment. A space. Circuit breaker compartment. It is located at the front of the switchgear. Mainly installed here is the high voltage circuit breaker. In this space, specific rails are installed. The rails allow the circuit breaker cart to slide and work inside. The cart can move between three different positions for easy maintenance of the circuit breaker. These three positions are the working position, the testing position, and the maintenance position. When using high voltage switchgear, what should be noted? During operation, before pushing the circuit breaker into the cabinet, check whether the circuit breaker is in the off position Check that the contacts are intact without deformation and not overheated or discolored. After pushing into the test position, close and lock the cabinet door. Only then can you move from the test position to the working position. This is mainly to prevent accidental short circuits and arcs from causing injury. After pulling the circuit breaker card out of the cabinet, immediately close and lock the cabinet door. Incomplete operation can easily cause overheating and equipment failure. During operation, if you feel a change in resistance or if the resistance is too high, stop the operation. Find out the cause. Do not force the operation. During inspection, when inspecting switchgear, only visual inspection is allowed, and through instruments and meters. It is strictly forbidden to open the front and rear cabinet doors for infrared temperature measurement and inspection. The doors of switchgear in operation should be locked and tagged as required. During maintenance, when maintaining a single compartment of the switchgear, pay attention to whether the bus bar is energized. It is strictly forbidden to open barriers or shield plates to prevent touching the stationary contacts and the lift parts. When maintaining the circuit breaker card in the switchgear, when the circuit breaker card is pulled out of the cabinet, it should be immediately locked. It is strictly forbidden to work inside the cabinet. If you need to work inside the cabinet, such as replacing rails or shutters, before opening the cabinet door, ensure that the equipment inside the cabinet is powered off and install an insulating barrier in front of the barrier. That's all for today's lesson. Thank you, everyone.